Okay, perfect. Um, okay. Hey everyone. My name is Raj. I'm a PhD student at IISc, and today we'll do the fifth iteration of the problem solving session. So we'll finish up the week 4 quiz and the week 4 programming assignment, and then we'll move to the lecture points that were there. If you have any doubts in that, okay. Um, Yeah, so we'll go to the first question of the week 4 quiz. Um, so we have this function called as mystery, and in this function, if L is empty, it returns L as it is. Else, it returns something weird, and here this it's a recursive call, right? So again, as the feedback is telling, it's about elements that are being moved from the end to the list of end of the list to the beginning. So we'll see how that is exactly happening. Okay. Uh, okay. So, so before we do that, what we'll do is we will let's write this return thing as a separate variable so that's easy to look it up. Ret val is return value. And now we'll see what happens, right? So when we pass this particular list. So here, obviously, first the list is not empty, so we're going to come here, and here we can see that the first. So what we're doing is we're saying that you want the elements from -1 to end, right? What do you think this will give as an output? When I give L of -1 colon, what does it mean? Anyone? You can unmute and answer also. So what will L of -1 colon give? What will this particular thing give us? So this basically gives us the last element of the list, but in a list form, right? L of -1 would just be 46, let's say here. But L of -1 colon gives us the last element in a list form. So it's a single element list, right? And then so that is what is there in the beginning, and then we're saying okay, you call mystery function again, but with this different argument, not with L exactly. Now, what is this different argument doing? So, what is this L of colon -1 going to give us? Any thoughts? So it's good. So L of colon -1 is going to give you the list as it is, but with the last element excluded, right? So again, remember in Python, the idea is that when you have something like L of A colon B, then until the B, until and excluding the second argument here, the list will be taken up, right? So in this case, now what's going to happen is we are calling the mystery function every time whenever we call, we're calling the mystery function with a list which is reduced in length in some sense, right? So basically speaking, that it is possible that it will reach sometime or the other to this particular base condition, right? Because we are calling every time with a reduced list, so sometime the list will end and become empty, and then this condition will be called, right? Now, so we'll see what happens here. So this is the first call where so this is the first call where L is the whole list that we have given, and then we're calling the mystery function again, right? Um, and then so here as we see, it's reduced by one. The last element is not present here, and so on. So again, the next recursive call followed by another, and this is the last recursive call. So here we will see that mystery will now call with an empty list, right? Because this in this particular context, when I do L of minus colon minus one is going to give us empty list, right? So this is going to come here, and here when the list is empty, a mystery function returns L as it is, right? Um, then what we get, as you can see in the previous call, we had L of L being 23. The mystery function then gave us empty list as it is. Now we are adding, we are having a plus operation between two lists, right? So that is basically going to concatenate the two lists, right? So in this case, we have 23 plus an empty list is going to give us the 23 list as it is, right? So that becomes a return value. And then we'll see again. Again in the previous call, so this becomes a return value here, 35 and then 23, and so on and so forth, right? So as you can see, what's happening is we are taking the last element as a list, and then giving the uh, taking the second last element in the next recursive call, and so on. So what will end up happening is you will end up getting a what you can say reverse of the original list, right? That's the idea. Okay, so this plus operation is valid because it's between two lists, right? Okay, that's the idea. So any doubts here, you can ask. Otherwise, we'll move to the next question. Any doubts? No? Okay. So for question two, um, yeah. So what is the value of pairs after the following assignment? Right? So pairs is basically given as a list, but then it's in a list comprehension form, right? So again, to make this things a bit simpler, you can just break it down like this, right? And see exactly what's happening here. Okay. So this basically saying, yeah. So this is basically saying that for X in this range, for Y in this range, and what the pairs list will contain a tuple of two elements, right? So it's a list of tuples, and each tuple has two elements in it. The values are X and Y. We know what the range that these values are taking, then there's a condition here, right? That is if X plus Y percentage 2 equal to 0. That is basically in this whole iteration that happens, only if X plus Y is an even number, only then that value gets added in the pairs list, right? That's how you have to understand this particular construction. Okay, so list comprehensions, you can use multiple for loops, and the way it will work is basically just it will end up doing a nested for loop, and if you have a condition, you can mention it in this way, right? So if the condition is false, then this operation, that is this particular element, will not be added in the pairs list. Otherwise it will be added. Okay, so let's just see print of pairs. Okay, so let's see if this comes out. Yeah, so as you can see, the first outer loop is X loop, right? That's going to come here, and then X becomes 6, right? And then Y starts becoming instantiated, and we get, so here you can see X is asked to go from 6 to 1, right? And decrement each value by 1, and Y is supposed to go from 3 to 1, and by decrement by 1 again, right? And then you check whether the value is even or not, the sum is even or not, right? um, and then you do that for Again, see, remember, this range value is take start, end, and then step value, and end is not considered, right? So that's how it's going to work, right? Um, yeah. Okay. So and you can see here that when 6 plus 2 is 8, so it is even number, only then this value, this particular operation gets done, which is basically construction of a tuple with two elements x and y, and then it resumes its operation back here, right? And remember again, 3 to 1, but it shouldn't take the value 1, right? So 3 and 2, both values are over. It will move to the next x value, right? As you can see, it is moved to the next x value, and then it will continue doing this over and over. Okay. So um, 3 and x being 2 is the last value it can take, and then this gets executed. That is 2 plus 2 is 4, so then that becomes added, that gets added. Now y will not continue its iteration because it has reached its last value. Even x has reached, and finally what we have is only these 5 elements that make it to the list. Okay. All are such that where the addition, the sum of those two values is an even number. Okay. Yeah, that is basically this list. Okay. Any any doubts here? So just remember, in list comprehensions, you can do multiple for loops, and the way it works is basically just going to be a nested for loop sort of an idea. Okay, so the first for loop becomes the outermost loop, and then the next loop becomes the outermost loop, right? If you have to do it in a non-list comprehension sort of a way, basically this is how you do it. You would say for x in range of so and so, then for y in this range, right? And then the condition comes in for x mod x plus y mod 2 equal to 0. Um, right? Only when this condition is true, you would want to add the pairs list, right? So pairs would append x comma y, right? That's what you want the list to contain. This pairs that you get now would be same as the previous one. Okay. So to pairs 2, you will see that it's exactly the same. So list comprehension provides you a easy way to do this sort of uh, computation. Okay, fine. So we'll move to the next question. Yeah. So we have a dictionary given to us that is goals, country, Ronaldo, Messi, Pele, and so on and so forth, club, and so on. Which of the following statements does not generate an error, right? So let's look at this goals dictionary in a bit more detail to be able to understand what exactly it has in it, right? Um, okay, so right. So what we see here is basically, let's say, um, basically, let's say, so goals has two keys, right? That is, one is country and club. So two keys are there. Country against country, you have another dictionary which is stored as a value, right? And in that dictionary, then you have like the keys, these players' names and some numbers given to them. All right. And then the club again has two entries. There is so the club again has a dictionary against it, and that dictionary has two keys, uh, Pele and Ronaldo, and then against them we have a list of 3 elements each. Okay, so this is what we have in the goals dictionary. So now let's just see what exactly each thing wants to do. So goals of club of Messi, 0 colon 49671 and 145, right? So let's say this, if I were to put it here, do I get an error or not? So any thoughts, will this give an error or not? So here what we're trying to do is we're trying to access a key called Messi inside the club dictionary, right? Which is not present here, right? So whereas right, so this will basically give an error, which is your key error, that there's no key called Messi inside this dictionary. Um, Again, same issue happens here also, because again what we're trying to do is we're saying you extend something, but there's nothing to be extended, right? There is no default value that is present here in this case, right? Whereas this is the right way of if you want to add a new dictionary here, correct? So that's going to be in this form, right? So here, what happens is we see the club of Messi basically has no value, which is fine, because what we want to do is we want to assign a value to this particular keys, and therefore make an entry in the dictionary, right? So this will not give you any error, and you can confirm that uh, the goals dictionary has changed by looking at the dictionary here. Okay, so as you can see inside the club, you have now a new entry called Messi with the values that you gave here, right? And versus, let's say again here, same issue is going to come here, which is basically saying that so here we say that we want to add something, but again something should exist at that level, which is what this will give you a key error. Okay, is is this clear? Any doubts? Let's say if you want to add some different kind of keys or different kind of values, you can ask. Hmm. Okay. Um, so question 4. So we have a empty dictionary called tickets, and then we want to see what among these will generate an error, right? So wickets of Muralitharan comma tests is equal to 800, right? Now remember the comma is inside the string, right? So this whole thing becomes the key against which you want to store the value 800, right? So let's just see wickets after this. So as you can see here, there's no error, and what has been stored is basically 800 against the key that is your this whole string. All right. Let's say if you want to do something like this, right? So here what we're saying that you want to create a new key with this name, and the value that you want to store against it is again a separate dictionary itself, right? Which is still fine, right? So this basically creates a new key here, and the value that's stored against that key is a dictionary with this key value pair. Okay, so again, no issues here also. Um, then again, let's come back to let's see this particular example. So here we have a tuple being passed as a key inside this dictionary. Is this okay or not? Can tuples be used as keys inside dictionaries? Any thoughts? Can tuples be used inside as keys in dictionaries? Yes, right. So they can be used, and you can see the output here. So basically, we have the key being the whole tuple. The tuple has two elements, which is the two strings, Muralitharan and test. Okay. What cannot be done is basically the last one, which is your having a um, list as a key, right? Because lists are mutable, it becomes difficult to, uh, actually here hashable. So that basically becomes a problem in creating the element here, right? So this becomes an error. Okay, so remember again, in dictionaries, we can provide integer, any immutable types, generally speaking, as keys, right? So your strings, integers, tuples, they all become a part of your, become, valid things to be provided as keys. Okay. Any doubts in the week 4 quiz? No? Fine. So we'll now move to the programming assignment. Okay. So here, so in your first question, basically, you have to write a function called histogram, which takes in which takes as input the list of integers with repetitions. So those elements in the list can have repetitions, which is fine. And it returns a list of pairs as follows. So here, the output has to be a list of pairs in which for each number n that appears in L, there should be exactly one pair, which is n comma r in the list returned by the function where r is the number of repetitions of n in L, right? And then the final list should be sorted in an ascending order by r. So we should not sort by the number. We have to sort by the frequency, which is your r, right? And for the numbers that occur with the same repetitions among arrange the pairs in ascending order of the value of the number. So for example, you can have two numbers which have the same, which have occurred same number of times. Then you need to order them um, based upon the this one, what do you call that, the value of the number itself. Okay, so again they have provided this uh, you know uh, 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 solution code here, so we'll see how that works. Okay, right. So we'll do the histogram one first, right? Yeah, so what we're trying to do, so again, remember in histogram, because you want exactly one number, one pair for each number, unique number, right? So basically what you want to do is you want to be able to count the frequency of a particular number. So for that, what we're doing is we are using the idea of dictionaries, right? So because in dictionary, the key is unique, right? So if you do something against the key, either it will change or it will get deleted, or it'll get added newly, right? So that is the huge point of dictionaries. Okay, you can maintain some information against that particular key also. So we do that using this function called as build table, and that is basically very straightforward. So what we'll do here is we'll just go through the whole list, right? One after the other, and then will say that if I have already found that number in my dictionary, uh, I just have to increment the count by one. If it's the first time I am encountering that particular number, then make the frequency to be one, right? So this basically is saying that already encountered it before, right? Encountered before. This is basically first time uh, encountered, right? This particular number. So you have to make the frequency to be one, right? So this gives you a frequency table. So this basically gives you the histogram, but in a dictionary format. And what you want in the output is not just that. You want to be able to sort the dictionary again, right? So that we will see how the sort function works. Uh, so for the sort function, it will basically sort by whatever is the first value in the list of tuples, and then by the next value, right? So then what we'll do here is we will use the frequency table and iterate over that frequency table to form that nice little list of tuples, which will then try to use this sort function to sort it out. Okay, so we'll see how these things work. So yeah, yeah. So we first have the list given to us like this, right? Um, and then we iterate one after the other, which the first time the frequency is an empty dictionary. So we'll add for the first time, first against 7 we'll add the value 1, and you can see this here, right? So against 7 we have added 1, and then again we have 12, 12 is also new, so we'll add again 1. 11 is also new. 13 is also new. So as you can see, we are basically we are basically keeping the count of the how many times I have observed this particular number till now, right? That's what this loop is going to tell you, right? And then we go to so here we have seen 7 the second time. So what we'll do is we'll say whatever has been the frequency till now, just add it one more, right? Because I have seen this number once more than what have been observed till now, right? That is what this frequency table is going to do for us, right? So 7 has become 2 and so on, right? So 11, 13, and then you have 14. So 14 is not present here at all. So 14 becomes the first entry, which we again add 1 to it. And then last number is 12, right? So that gets added up here. And then so therefore frequency is basically just the a dictionary having 5 entries. The 5 unique numbers are present as the key, and and the and the frequency is present in the values, right? So then we'll go to the sort table function. So where we are going to sort this particular frequency dictionary as a list of tuples. So here, again, remember this is a list comprehension sort of a setup, right? So where we can again break this down neatly here. Um, just so frequency table we are sure of how we get, yeah, so fdict is going to be this one, right? um Again, remember what are we trying to do? We are so in this setup we are basically saying you iterate over all the keys and then give me a tuple of two numbers with the frequency first, because fdict of n is going to give you the frequency of the particular number and then the number, right? So this is sort of reverse, right? So okay, we are basically getting the list in this form as r comma n, right? So that you can see here. Um, yeah, so f list, as you can see, uh, it's 2 7 2 12 and so on, right? Now f list dot sort is going to sort this particular list in the increasing order of the first value, which is the frequency, and then the second value, which is your the number itself. All right. So that's going to become flist.sort. So as you can see very clearly, the 1 comma 14, which was in the last, has become the first now. And this sorts in place, right? So flist gets changed by this particular, operation. And again, remember, we don't want in this form. We want the number first and then its frequency. So we're just trying to flip it again, right? So again, let's just see this is again a list comprehension sort of a setup, right? Okay, so what we're saying, we are saying for r comma n in f list. So remember, if you have so in a list, if you have like a list of pairs, if you write it in this form, the first number gets assigned to r and the second number gets assigned to n. Okay. Uh, by the way, uh, help me understand if something like this was there. Let's say if I had l equal to 2 3 4, right? And then 3, 4, 5. And if I were to do something like this, A comma B in L, right? What will happen here? So I have a list. I have two elements in this list. They are two tuples, right? And tuple of three elements. But if I give something like this for A comma B in L, print A comma B, what is going to happen? Any thoughts? Anyone? Who is this BA? Punit Aditya, I cannot hear you if you're saying something. It'll give two tuples together. Why? Because you are trying to iterate over the list, no? If you are trying to iterate over the list, shouldn't each of this iteration capture one element in it, right? So any thoughts what would happen here? And again, the counterpoint to your idea. So let's say if I had say 5, 6, 7 here, an odd number of things, then what will happen, right? So do you guys remember this one? So let's get a new file itself, right? So if you remember from previous this one, so if you have like let's say a b equals to 3 comma 4, right? If you do something like this, what happens to a and what happens to b? What's the value that a and b will take separately? Correct. A is 3 and B is 4, right? And that's because we are doing the tuple level assignment, right? Guys, just a moment. Yeah. Um, correct, right? So we will have A becomes 3 and B becomes 4, right? Let's say if I were to do something like this, 3, 4, 5, then what will happen? Any thoughts? So this basically gives you a error, right? It's a value error. So basically the idea here is that Python cannot assign this whole tuple as it is to A and B, because again, this is basically not possible to understand, right? So because I could assign 3 comma 4 to A and B can get 5 versus A can get 3 and B can get 4 comma 5, right? So these sort of combinations are possible, and which is why Python says there's no possibility of assigning the values at all, right? Um, okay, so is that clear? So this sort of thing won't work. Okay. If I were to do something like this, something like this, let's say if I do A comma B as 3 comma 4 comma 5, but 4 comma 5 is again inside a tuple. What will happen to A and B? So what is A and what is B? Right. A is 3 and B is 4 comma 5. That is basically A will become the um, yeah. So here, because what the idea is that B will be given the tuple 4 comma 5. So this tuple that I have here has two values. The first value is an int. Second value is another tuple. So there are two values at the end of the day, and the output has to be. I mean here on the LHS I have again two values. So they can be assigned one by one, right? So hence A becomes 3 and B becomes 4 comma 5. So on those lines, if I were to do something like this in this particular loop, what do you think will happen? Will this loop work? Right? So it'll give the same error, right? Because in this case also, when I give for a comma b in L, so it basically iterates through the L elements, right? The elements of L. That is it first is 2, 3, and 4, and tries to assign it to a comma b, which is not possible, right? So hence you get the value error here. Okay, so in this case, in our case, although we don't have that problem because we have um, yeah, so we have basically a list having tuples, and each tuple is basically just two elements, right? So hence that gets sorted in that way. So we get R and N become the take the first two R basically has the frequency and has the number, and what we want in the output is we want the output to have the number first and then the frequency, which is exactly what why we flip this particular pair. Okay, so this we will basically, let's see how what it prints. Okay, so we see 14 comma 1, 7 2, 11 2, 12 2, and 13 2, right? So 1 is the lowest frequency, and then the 14 for the number in that case, and 2, so all the others have 2, and then so we have done the um, sorting based upon the number itself, right? Okay, this is the final, I mean, the solution that was is present, right? Any thoughts or any ideas on, let's say, if you any thoughts like how you did differently, or you think this was not good, or if you have anything more interesting to for me to try, we can do it now, right? If anyone tried solving this and did it in a different way, you can let me know. Collections library. Yeah, correct. So collections library, by the way, to people who are counter. Okay, counter function is one thing, and then you can basically also use something like from import default dict sort of things. So default dictionary is basically a construct which is provided by this collections library to handle this sort of a scenario, right? So you don't have to check every time whether the key is present or not. Rather, if it is not present, it basically just uses the it creates a entry in that particular dictionary by itself, right? That is what this is basically help you to do. Rohit, lambda function, how have you used lambda function? Guys, just a moment. Right. So this basically this idea of sort, right? So here, um, yeah. So this we did this flipping of we first made r comma n, and then we flipped it again. So instead of doing that, this sort function itself, the sort method itself has a way of telling you what is the key that you would want to use, right? So let's just try to do that. So def sort table, let's say v2 f date. Okay. So, so now you have, so let's say we'll make the f list here. Okay. That's going to be your, so for n comma r in f dict of dot items, right? So this is another way of doing this particular, this one. So you can either take dot keys and then access the key value, the value against it in this way, or you can write dot items. So dot items by default gives you the key and then the value stored against it, right? So in our case, because we're storing the number and then the frequency, that's exactly what we have in this form, right? So then what you can do is you can do flist.sort, and here the sort function takes a argument called as key, right? So key tells you, you written it here, right? Yeah. So key tells you what is the order. What is the way in which you should sort this particular list, right? So it tells, what we're saying here is we're saying you sort this list using based on a tuple, and that tuple has basically the first one being the second item of the list, right? Which is basically, in our case, this turns out to be, so here the key basically becomes the r comma n, right? Because we're doing x of 1 comma x of 0. So x of 1 is basically the r, x of 0 is n. So this becomes the key, right? Which is what your sort function will do. Here, by default, it takes the first element and then the second element, right? So unless you give this key sort of a, argument. Now, once you sort that, you can just return flist by default, because this sort method is in place, right? So it will change the list, whatever you're given, right? So if I do v2 here, and then run this program, you'll get the same sort of an output. Okay, fine. So, okay, hopefully this was clear. Um, then, any other doubts or ideas somebody want to present, you can present, right? Otherwise, we'll move on to the next question. Okay. Um, so the next part is about transcript. All right. So the transcript question is as it is. So here basically saying that we have a three separate lists which has the academic information, right? One is called the course details, which is basically tells you course code and course name, which are both in entries in string. Student details, which is basically a list of pairs of form, roll number, and name. Again, both are strings. So given a roll number, if I want a name, I would get it in this format, versus and vice versa, right? But again, that is only true if the names are unique. Then a list of triplets of the form. So you have three strings, right? Where you have the roll number, course code, and grade. So basically, this roll number in this particular course code got this particular grade. Okay. Uh, Each roll number and course code in the grade list appears in the student details and course details respectively. So basically, whatever roll number are present here, you will have that value against it here, and course code, which is present in the second element in this triplet, will have some entry in the course details. Okay, fine. So then you need to write the transcript function, which basically takes these three lists as input and gives you a consolidated grade for each student, right? So you want the output to be basically the roll number and the name, and then a list of all the scores that they've gotten, basically the course code and the name and what the grade they got, right? And you want again some other things. Basically, the tuples have to be sorted in ascending order according to roll number. That's here in this transcript, and then each student's grades also should be sorted based on the course code. Okay, so for that, again, remember, we just need to be able to map items from one list to the other. So this sort of function is actually quite straightforward, where you just need to build multiple dictionaries. The idea here is that you need to be, I mean, what do you use for sorting? and where do you sort? That's the main challenge. Otherwise, everything is quite straightforward in that way. So let's just see what we have. So yeah, let's just do one by one. Keep this here. Okay. Uh, okay. So what we'll do is we have the course details. We want to be able to map the course code to course name, right? Why do we want to be able to map the course code to course name? Is because we, in this particular output we want uh, uh, we want the course name against the course code also, right? And because we have grade only at the course code level, right? So we have like MA101. What was the grade? So if you want to combine these information, the course code to course name will be a better option to have, right? So that's exactly what we are building up here, and you can see the dictionary here again. Very straightforward way how we did in the previous example, where we are sort of storing the course code as the key and course name as the value, right? Again, similarly, we have the student dictionary, which basically has the roll number and the name. Again, remember, because the list has uh, it's a list of tuples. The tuple, we have two values in that tuple, so we can use this roll number comma name as a construct here. Okay, and that gives you the dictionary, which is this particular thing. So we have two students here, right? And then we have the grade dictionary. Again, grade dictionary, remember this grade details is basically having three elements in it, in the tuple. So we are using three values here. That's the roll number, course code, and the grade, right? And what we and we do the same thing here. We are saying that if the roll number, we've already seen the roll number, then you need to just append the course code and grade. Otherwise, you need to make the new entry in the grade detail, grade dictionary. Okay. Um, right? So now remember, we have to do two sortings basically. First is we want the the final list to be sorted based on the roll number. So we're using sorted of gradient of keys. So gradient of keys gives you some sort of an iterable, and then you're sorting that keys itself. So and in that order, you will be entering information in the output list. So hence the order will be maintained. So with that, you go inside this particular for loop, and then your grade list also has to be sorted based upon your course code, right? Yeah, course code, right? So if you see here, grade dictionary. So R is in this case, first of all, this roll number. So remember what we have in grade dictionary is a list of tuples. Again here, two elements, both are tuples. And when you do sorted again here, it is basically going to sort based upon the first element. If the first element are the same, then it will go to the second element, right? Again, because course codes are generally, I mean, will be unique. So there's no need, it'll go to the second element ever, right? Uh, and again, remember, this is a list of having two elements. So we're using C code and grade as the input here. Okay, so that is basically just going to add the elements in the grade list in order, right? So now what do I have? I have the grade list, which is in order of the course code. Then I want the roll number, which is again in order. So which is got which you get here. And I want the name. The name is, we get the name from the student dictionary, right? So we have used all three dictionaries here to be able to map from one element to the other, right? And then you will do that for your next student also, right? So output list basically has two elements in the list. First element is a tuple having three elements, right? So that's a code, roll number, the name, and the list of their marks. Again, ordered by the course code. Similarly here. Okay, fine. So this is basically your programming assignment 4. Any thoughts on this particular thing? Any doubts or any different strategy you used to solve the problem? You can let us know. It'll help all the students. No. Okay, so dictionary and so on, they basically help you to map items from one place to the other. Okay, so we'll now move to the week 5 syllabus. I mean the lecture stuff, right? So where so first thing what we have is the exception handling. We had done this last week. So I'll just go through it briefly, right? So so we discussed two ideas here in this particular file. One was the idea of having multiple exceptions, right? So where you can have, let's say, the idea of exception handling is that, let's say you expect some sort of an error to happen. Instead of waiting for the error to happen, you can try to handle the error in a more graceful way, right? So here, for example, let's say I might have some sort of an error which is saying that this x plus 3 I've mentioned here, but there's no definition of x here, right? Or I'm trying to do, let's say, a division by 0, or I'm trying to, let's say, use some sort of a dictionary key which doesn't exist, right? So these sort of issues will can come when you're coding, or when your program is a program runs. So to be able to handle these exceptions, we use this try except block, right? So we say you try to execute whatever is there in this particular part of the code. If there are any exceptions which are zero division errors, then you come to this particular part of the code. Otherwise, if there are any name error or key errors, you come to this part of the code. If there are any other exceptions, then, then you can come here. If everything runs happily, there's no issue while running this particular part of the code, then you come to this else block, right? Which says all hunky dory, right? So if you try running this, and the idea is, if there are multiple exceptions also, the first exception that is raised, that will be basically handled first. Okay, so in this case, though I have written zero division error as my first except block, but because the first error which is going to come is basically this name error, which is basically this variable was not defined. This part of the code, which is your name or key error, will be printed, right? So we'll see that happening here, right? That's exactly what we see here, name and key error. Okay, so um, and let's see the flow of control. So it's going to come here and then print this particular ID and go forward, right? And then let's say if this was not executed, so then the first error which I have is basically the zero division error. So that's basically caught separately, and you get this part of the code here. Okay. Um, and then let's say yeah. So now I have a dictionary which and I'm trying to access a value against a key which is not present in this particular dictionary. So if I do that, I'm going to get this name or key error, right? Because this basically is a key error. Okay. And then I do this other issue, which is basically, let's say I have a list which has only one element, and I'm asking the program to give me the third element, which is does not exist, and hence that's the error that we are getting. It is this index out of range. And then in this particular block now, this is all comments, right? So this has no problem. So now if I do s equal to high, this is just a trying to assign a string to a value to a variable, which is fine. So that is going to print this else part, which is saying that everything is hunky dory. Okay, so you can catch multiple exceptions in this particular way using a try except block, and else part tells you whether the try block executed without any issues. Okay. Next is the idea of flow of control. So where we said where the idea is that let's say when you're calling functions one after the other, then it's possible that some internal function raises a exception, and that need not be handled at that function itself, right? It can be handled at any level above that particular function. Okay, so now here let's say I have a function called f that calls g, which calls h. right? And inside H, I have some sort of a code which may or may not give some errors, right? So here we see I have k is given as L2, and I'm trying to access the key K of this dictionary K, right? So this is going to give an error now, but there's no try except block around this. But whereas where the function this h is being called, there is a try except block. But again, this is very specialized to capture only zero division error, right? Uh, so hence this the flow of control goes back to the above a layer and says, okay, here I have this a global sort of a function, exception handling present here, and that is basically used to capture this error, right? So you can do here, and we'll see that this basically prints this saying that there's some other error. Okay, so if I were to have this sort of a thing which is says x divided by 0, that is basically going to be caught at the level of G itself, right? So wherever the first time it gets caught, that is printed, not at the higher level. So here you can see that I'm trying to capture the zero division error in G function itself, right? Though F function has a separate block to handle the zero division error, because it's already handled at G level, we only get at this particular level. Okay, this is the idea of flow of control. Okay, any doubts here? Anything, any combinations you want to see? Uh, if you have doubts, let me know in a minute. No? Okay. Um, we'll now move to, yeah, handling files and standard input output and that sort of a thing. So, so yeah. So let's say I have this file called as input.txt, which has these two lines. If people have read what, how to, so let's say if I want to read the elements of this particular, I mean, read this file as it is, complete file as one string, what will be uh, the way to do that? If I want to read the contents of this file input.txt completely as one string, right? So how do I do that? So I have some f open, and then what what aspect of f do I use to read this whole uh, content? It'll be f dot read, right? So if I write contents as f dot read and f dot close here, and I do print of contents, right? So you can check what the data in contents is, basically the whole whatever was present in the input.txt file. Okay, so yeah, so okay, so if I want to write, for example, the same contents back into some other file, right? Any thoughts? How would we go about doing that? So for that, what we do is basically saying, let's say I can create a new file, and you give the file name here is basically, let's say, duplicate or txt. Okay. And here, what we want to write is we want to write contents into this particular file. So we need to open the file with permissions of write, right? Here by default, what happens is we get the permissions of read, right? So if you don't mention what the mode here basically is, you get the read permissions, and you can read from this particular contents. So if you want to write here, we then say f dot write the contents as it is. Okay, and then f dot close. will basically make sure that your contents are written to the disk. So as you can see, we have a duplicate .txt which has this exact contents of input, right? Um, Now let's say if you want to do something like read line by line. So for that we have a function which is basically saying um, f is equal to, let's say, we'll open it again, right? And for that what we get is we get content as let's say list of strings, right? Content list. So we can do f dot read lines, right? And then let's say we use f dot close. And if you print this content list, you will see that this gets read as a list of strings, okay, with the additional new line character at the end. Um, is that clear? Um, and by the way, so instead of doing this f dot close, f dot open every time, because it's possible that sometimes you might miss what like you've opened some file but then missed to close it, and all of that can cause issues in your file reading and file usage. So for that, what Python does is provides a very nice method. Let's say something like this, as f, right? So this with basically opens up a context sort of a block where you can use this f as if you were doing this, and once the code inside this with block is over, it will call the f dot close by itself, right? So basically the same exact thing you can do it here, and then say, okay, I want to print the content list as it is, right? So this sort of what you were doing here, it's exactly equivalent to what you were doing here. So this allows you to not worry about closing files and all of that. This the with context already handles that for you. So let's just see if that works. And you can see here we have read both the lines as two separate elements in this list. Okay. um, Now, let's say you have a special sort of a file, a special sort of a file, let's say, which is delimited in some way. For example, let's say you have this sort of a list file, right? So where you have, let's say, entries in each line, which have a special character like semicolon and then a space and so on, right? So let's say you want to read all the elements here and also be able to parse them from this file, right? So then what you can do, you can say right, and use R here as F. Again, we'll use this sort of a thing to make sure we don't miss closing the file. And you can do F dot read lines, right? So now we have read all the lines, all the data in this content list, right? But again, remember in this method, the last character in this in each string will basically have a new line character, right? So let's just put that here and we'll see whether we read it properly or not. Uh, no such file or dictionary. Acha, oh, document.txt. Yeah. So as you can see here, so we have this new line character, which is not basically useful for us. So we will see if we can, remove this, right? So we'll do like, um, let's say we'll use um, content list. We'll use list comprehensions and we'll say string dot strip, right? So again, remember dot strip basically removes all the elements, all the trailing and the spaces at the front and on the back of the string, right? So let's just see if this works. So as you can see, so initially we had the neuron character in the at the end, whereas now we don't have the neuron character. Now what we'll do is, let's say we'll try to make so for string in content list, I want the elements of each string as a list of the three things that are present. For example, let's say I want Raj first, and then CS89, and this year as the third element, and so on. So for that, what we'll do is we'll use this idea of split, right? So split you can do based upon, let's say, a semicolon and space. If I give, it will split this particular string, this complete string, into parts based upon this character, right? So here we have three parts here. Let's see if the thing works as it is. So so, so we can see that I have now been able to split the string between into three parts. That is this Raj, CS89, and 2025, and so on and so forth. So each of the three strings have now become three lists by themselves. Okay, so this sort of an idea will be useful in doing your assignment number, I guess, 5. Yeah, right. So because there also you need to be able to read content in which has some delimited sort of a character, and then see how to process that particular strings as it is. Okay. Any doubts in this part about reading, writing, and basically how you can do simple operations on string like strip and your split? Okay. Okay. No doubts. Fine. So this is basically in your standard input output and stuff like that. Um, yeah. Um, so in your so shall we move to week 6 then? Um, there are no doubts on um, week 4 contents, week 5 contents. So so in week 6, you have this idea of this global scope and nested functions. So I thought I will better get started with something like that. So let's say you have a function, let's say something like this, right? So uh, you're defining a function f, y is equal to x, print of y, and you have not defined x yet in the function, right? But before the function was called, you have defined x, saying x equal to 7, right? So in this particular scenario, what will end up happening is you will this x will end up using the value which is present outside. That is basically whatever has been present till now. It will use that to make the operation here. Okay, so but let's say if I were to do something like this, x equal to 22, right? Now you can see it's here itself that the compiler has, I mean, the ID has given an issue, but let's see what's the issue here, right? So we're saying that local variable x referenced before assignment, right? So here you can, so basically what ends up happening is in your function, what all variables are, being used, right? That the Python has a sort of like a list maintained. If it sees that okay, x was not defined initially, here there was no x being used in the function. The idea is that it will see okay, if possibly there is some global function where this a global level where this x value might be present, I will use that to assign the value to y, right? Whereas in this scenario, it will say, okay, x is supposed to be a local variable, not this sort of global variable, and hence this y equal to x gives an error. Okay, that is how this would work. But let's say if you want to be able to use this, value itself, so then what you will have to do, you will have to use a special command saying global x. This basically tells Python that whatever X you're using, you see here, there has to be the global level X, which will be provided in some way or the other, right? So in this scenario, what will happen is you will see that X, this function works as it is, and you can see what happens to X value also here, which is basically 22, change to 22. Right. So global X allows Python allows a function to be able to manipulate the value of X, right? By with this particular sort of a statement call. Okay, so that this basically tells you the scope of the variable, whether x has a scope that is present outside the function f or not, right? And this exactly sort of a thing can be used even in with functions itself. So let's say if I define a function, let's say g of a, and see where I'm defining this function, by the way. Um, I'm defining this function g of a inside the definition of f. Okay, so if I were to try doing something like g of 3, this is going to give me a problem because g cannot be accessed here. Uh, there's no definition of g present, right? Only f knows what g is, right? So that is what defines the scope of the function g. So function g can only be used inside f. So that what I can do is, now let's say if I do something like let's say return g of 10. Okay. And let's say I'll print what I get from f. Let's see all of this. Yeah, so now I'm saying you try to return this g of 10, and you'll see that this returns 11 very properly, right? So so basically what's happening is when I say return g of 10, g function is known to f inside f. So this calls this function here, and this returns 11 to the calling function which is here, and this returns 11 as it is, right, to the calling function here. Okay. Additionally, let's say you have something like this. Mm, y is equal to 10. And if I do something like plus y, right? Um, Here what's happening is basically we're saying y is available inside f. G is defined inside f, right? So G has access to all the variables which are present inside f also, right? So though I have not defined y inside G function, because y has been defined inside f, it has access to that particular variable, right? So if you see here now, you're going to get 10 plus 1 is 11 plus 10 is 21. Okay, so this defines the scope of y. So y is a local variable for f, but it has a sort of a global sort of a presence for g. Okay, and again remember, if I were to do something like this, y is equal to a plus y, right? You can see immediately here it's showing a unresolved reference, because the fact is we are saying that y is sort of a local variable now, right? We're saying don't use this particular y, but this g function itself has a y in it, which is specific to this g function, and that has to be used. But that was not defined clearly here. Hence, this gives a error. Okay. And again, remember, if I use global y, right? So this says the Python, code that whatever y I'm going to use inside this function has to be a global level y, which is basically defined in f function, right? So that basically becomes so okay, global has to be something like somewhere here, I guess, right? So that becomes your global function. Okay, so this is the idea of scope and function local variables, global variables, and how a particular function can be accessed or not accessed outside a particular function definition scope. Okay, any thoughts? Please let me know. Otherwise, we'll move to next part. No? Okay. So we'll go to the idea of, let's say, this idea of called something called as backtracking. Um, so remember, when you're trying to solve a particular problem, right? Not always in the first try you get what what you want to achieve, right? So it's possible that you try a few things and then say, okay, this particular a step didn't work out. You will take a step back and then try to reevaluate, let's say, what you have observed, right? So this sort of idea is called backtracking, where you go in some direction and then you say, okay, this has led me to a place where the solution is not possible, and I will go back in time and try to reverse my moves and see what will now work from this point forward, right? So to to basically motivate the idea of backtracking, so in this what they have used is basically trying to place queens on a chessboard, right? Now remember, when you place a queen at any location, the queen ends up blocking, let's say, that particular row, the particular column in the chessboard, and also the respective diagonals, right? The respective on diagonals and off diagonals. So so then what we do is we are trying to place, let's say, if I have a 8 by 8 chessboard, I want to be able to place 8 queens on that chessboard, right? Such that no queen is actually attacking the other queen, right? So all the queens are basically being able to live in coexist on the board, right? So for that, what we do, the idea here is that you try to, let's say, we have a function called as place queen, and what we're trying to do is we are saying that if uh, I can place, if a particular region is free, right, then I would add the queen to the particular location, and if I am and if so once that is done, I'll try to place the next queen on that on the same board. If that solution works, then I am done. Otherwise, I need to undo my current move, right? So this is exactly what this sort of a recursive call is doing here. You're saying that if a particular location is free, you add the queen and then try to place the next queen on the board. If that worked, then you're done. Otherwise, you have to undo this current whatever you added queen on the board, right? That is basically what you're trying to achieve here. Okay, so we'll see how it's being set up here. So basically, let's say we define the chessboard as a dictionary having sorry yeah. So we define the chessboard as a dictionary having, let's say, multiple entries here. We're saying that, okay, each queen is basically not yet assigned. Each row is sort of free. Which queen is going to sit there is not it's empty. Each row is empty. Each column is empty. And then this NW to SE basically means northwest to southeast, right? So basically from the northwest to southeast, that diagonal basically that is empty, and also the southwest to northeast, that diagonal is empty, right? Because again, queens they block 4 directions. Okay, so with that, then we'll try to place the first queen. First queen is basically queen 0. If that queen gets succeeded, we'll go to the next queen and so on. So I just need to call it once, this function, because this calls itself recursively. It will then end up giving us the final board here. Okay. Um, so now let's see if we can figure this out. So yeah, yeah, 8 queens. Yeah. So you're trying to place 8 queens on an 8 cross 8 chessboard. Um, So n is basically 8. And then we're trying to see this j basically tells you, uh, sorry, I tells you which queen number you have to add up, right? And now we'll see whether if free of I comma j. So free, whether a particular place is free or not is basically defined based on this condition, right? So let's say if that particular row is there is no queen on the particular row, if there is no column if there's no queen on the particular column, or in that particular, northwest to southeast direction, or in the southwest to northeast direction, that basically tells you that that particular location is free, right? We'll say that we will add the queen on this particular location, which is J. Okay. So uh, so we then see, okay, so this particular board is this particular location is free because obviously there's no queens yet added. So we then say try to extend this particular solution with adding the next queen. So we'll now move to the next location and say, see if this particular, if this I comma j is free or not, right? So huh, so what we're seeing whether a particular queen can be placed on the jth box, right? So that is what we're trying to see here, and we see that that particular row is not free, and we and once you find the first row where it is free, we try to add the queen. Okay. um, and after adding, we then ask to continue with this particular assignment to the next queen. So I is equal to 2 tells us it's the third queen, and then we see whether the rows are free or not. So again, j equal to 1, and here we have a nice little way to check whether the board is free or not, right? So as you can see, the zeroth row has the zeroth. I mean, the first row has the first queen. The second row has the second queen has been assigned to the second third row, and then we are continuing with that, right? So again, here you will see that j equal to 3 is also not free because that will be blocked by the queen number, second queen that we had, right? And 4 will become free, and that's exactly what we're doing. We're saying add the queen number queen 2, that is third queen, to this particular row. Okay. And then we place the next queen. So until 3, everything will be fine. Let's just see where we come to. Yeah, undo queen, right? So let's say we do the print board. Huh. So now what's end up happening here is that basically we are not able to find any location for this particular queen, that is queen 4, or the fifth queen, right? So basically there was some location, some step that we were in which didn't work out, right? So hence we need to undo that particular operation. So that undoing basically works in this way. You're saying that you remove that whatever you had the assignment. So it's exactly opposite of what you were doing in the add scenario. So where we said that queen of yeah, so the queen of basically I becomes again -1. You're basically resetting that particular location to -1, and the other locations are being set as free. Okay, so we do that, and then you do this operation over and over again based upon whether the queen is placed or not. Okay, so this is the overall idea. And let's say if we were to basically run this out. Yeah. So what we're saying here is that the first queen was placed in the first row, then the second queen was placed in the second, fourth, or the sorry, the fifth column, and so on and so forth, right? So this basically, this arrangement tells you whether if you place the queens in this particular form, then you will have no problem in the queens attacking each other. Okay, this is the idea. Let me know any thoughts or doubts on this. Then, otherwise, we can take questions for any other uh, problems that we have in that. Okay, so yeah, so for your week 5 programming assignment, again, remember what we discussed previously. You need to be able to map the course codes and the semesters and etc. from this particular information to your students information, right? And your with the grade here to be able to get the final format, which is basically what is the roll number, what is the name, and then the grade point average. Okay, so that will basically tell you, so in this, to get the grade point average, you will have to try to see all the information about the grades, and then um, here, because your input is going to be having this special symbol like tilde, you will need to do something like your split sort of a function, right? And then try to see how to map information from one list to the other lists. Okay, that will basically give you a final design. So any other doubts in your in the exceptions or exception handling or file input output string functions, do let me know. So we covered this idea of pass, del, and all that briefly in the previous iteration. Um, but again, uh, the point in basically this. So pass basically helps you try to tell Python that we don't want to do any operation at all, right? It's sort of saying no of condition, no operation, right? If you don't want to do something here, then this sort of a thing you can use, right? So let's say, for example, if you are trying to do some sort of an assignment here, and you have some exception, and let's say you don't want to do anything in the exception, right? But you also don't want it to propagate and basically kill your function. Then you can do something like this, right? So in this scenario, if you see, this is just going to be very silent, because you're saying if there's exception also, don't try to do anything, right? That's your that's the main use of your pass sort of a construct. um, then your del operation basically helps you to delete items from a particular list, right? So let's say if you want to do something like this, let's say you have a list of and so on, right? If you want to delete the item, let's say the 5, right? One way of doing this, you would say something like this. You would say L until you want until this element. So you say 0, 1, 2, it's your 2, right? And then L of 3 colon, right? So this L1 now will not have the element 5. Let's say you are trying to delete element 5, right? Delete element 5, delete 5, right? So this is one way of doing it, right? Right. So this one way of doing it, as you can see here. Otherwise, what you can do is basically use this idea of del operator, right? So del L of, let's say, 2, right? This will remove the element from the list itself, right? And then therefore print of L, this will basically remove your element from the list. Okay. Obviously, you can do same thing here, and you can just assign this list back to L, right? So this is one use of del. The other is basically in a dictionary, right? Let's say you have a dictionary which says something like year 2005, month is 12, and so on. If you want to remove the key of month, then you will say del D of month, right? And if you print D here, that's going to remove that particular entry. Okay, you'll have only one entry here, right? So del, and also additionally, del can help you basically delete a very large object, for example, in memory. For example, let's say your code is running and some variable starts consuming more and more memory over time, and you want to clean up memory from time to time, then you can use this del operation to clean up that particular thing. That doesn't uh, force the Python to clean up, but it tells Python that this particular variable is free, right? So then this particular RAM memory is free. So you can then the OS can then choose to use that location for whatever purposes it wants. Okay, that is one use of del basically. Um, and none, again, as we discussed last time, it's very useful when you are trying to do something like this, where you have a function definition, okay, and you don't have a value to be given yet. Okay, so if let's say you can check if L is none, and you can assign some sort of a value here, and then continue your rest of the function which uses L, right? Right? So in this case, what will happen is user in somewhere else a print of L, right? So in this case, what will happen is it will basically end up if we provide L value, it will use that L value that's being given. Otherwise, it will just use the default value. In this case is 10. Okay, so this sort of a usage of none is there. Additionally, let's say there is something that you say when you're trying to solve for, but you don't have the value yet, then that all of that operations can be captured using none, right? And let's say you have some sort of a part of some code here, which brings in X from somewhere, or if it doesn't bring in X and so on, then you can basically check whether if X is none or not, and then continue your other part of the code, right? Okay, so this sort of a usage is there for this idea of none, and this becomes useful mainly in your function definitions, or in, let's say, when you're trying to see whether a particular value exists or not, right? So instead of having a default value previously, you can assign it to none and then use that as your go-to way of trying to understand whether something exists or not, and so on. Okay, so that's your del, pass, and none. Um, yeah, so the other thing that was present is printing formatting printed output. So that basically is very useful when you want some sort of a fixed sort of a way of you know um, printing stuff nicely, right? So let's say you have yeah, so let's say you have a string um, which is sort of like this. Um, so 0, 3D, right? And then format, and then 10, right? Right. So this basically prints the string in this form where you have like a three space given for this value 10, right? Let's say if you give a number which needs larger space, it'll just end up giving the larger space, right? So don't worry that if you give 3D and then it will end up cutting information from here, that's not going to happen, right? There are other ways of using this sort of a thing in Python 3 at least. These are called as f strings, right? So where you can format the string in a different format. So let's say if I give x equal to 1000 here, and then I can write x here, and then give whatever, let's say, you want to format in some way you want, right? Let's say if I do this, um, yeah, it's going to give the same thing. Or let's say if I were to do something like this, let's say um, uh, ND, right? Yeah, 10D for example. Then so this basically is called as the F string. So that allows you to use the variable names as it is, right? So here, unlike here, what happens is it will use a zeroth argument, the first argument to replace with zero and then one, and all of that can cause issues. There are other ways to fix that also. So you can write, for example, let's say, I think X here and then write X here, X equal to 1000, right? This also works in a similar way, right? In a similar way. The idea here is that so I prefer something like, sorry, I prefer something this like a F string, because that helps you to keep everything as it is. You don't have to do this dot format, etc. This F basically means that it's a formatted string, right? So whatever values it needs will come from the variables present at that particular point in the program. Okay. Um, yeah. So, and this also allows you to do additional sort of things. For example, let's say I want the square of X and not just X. So I can do X squared, and then you can do other, stuff here, right? So that's going to print your X squared in this form. Okay. So this allows, it becomes very handy when you want to do something just for the sake of printing, right? And then that becomes simpler to, maintain the code and so on. Okay, so we'll close the session today here, and we'll meet um, next uh, when next Tuesday, right? Same time. Yeah. Thank you.